My name is Sethu Vijayakumar. I'm a professor of robotics at the School of Informatics at the University of Edinburgh, and I also direct the Edinburgh Centre for Robotics. So already there are many scenarios where robots are much more precise, much more accurate, much more cost-effective than humans in many jobs. For example, you can think about classical manufacturing and packaging industries where the very mundane job of repeating things again and again very precisely is something that humans very easily get bored, whereas robots and machines don't. But going away from this more traditional robot application domain, we can think of things in medical industry where the robots can overcome some of the basic fundamental shortcomings of humans in terms of things like tremor, accuracy, precise maneuverability, and basically create much higher precision. We are already seeing technologies where machine intelligence is overcoming the boundaries set by human intelligence because of overcoming the sheer capacity of storage, sheer capacity of computation. So now you've got computers which are able to both store large amounts of data and compute much faster than human computational power. We are able to now get patterns that are not visible to human eye or human intelligence. And using those clever patterns, we are able to really exploit the data in ways that we've not thought about before. So things include targeted marketing, targeted drug delivery, targeted or personalized healthcare. So these are areas where I think machine intelligence, it's creating a huge difference, and it will continue to do so. It's a concept that I've championed over the past few years. So it's actually a very interesting and novel concept in terms of human-robot interaction. So on the one extreme, you've got robots that are completely teleoperated. What it means is if you have a joystick or some sort of mechanism in which you sort of strap yourself in, and if the robot mimics your actions, and that is teleoperation, and that is the classical way of operating robots. On the other extreme, you've got fully autonomous robot behavior where there's no human input and the robot makes decisions on its own. What I feel the next challenge, the next big frontier in robotics is this concept of shared autonomy, where we will have humans in the loop while the robots are still doing lots of tasks autonomously on its own. It is much tougher than the pure form of teleoperation or autonomy, because this sort of human-robot interaction is a very sort of mixed bag kind of in terms of control is really hard. But I think that is where we will see the maximum benefit arising by exploiting the best of both worlds. The contextual decision-making of humans, the ability to recognize concepts and use prior knowledge effectively, and marrying that with the preciseness, the repeatability, and the efficiency of robotic implementation.
It's kind of like a filing cabinet, but where all the files are connected to each other.